Thank you for joining this session. I would like to share with you now the things that we are doing at AVL. And as you know, infotainment is not our primary business, yeah? But we are well into ADAS. And therefore, first I will try with a disclaimer. Although it may look, the first 2 slides maybe like a sales pitch, it is not, okay? And so the reason I'm wearing this hat is because I get blinded by this reflector over there, so apologize for that. So, okay, the ECU. Yeah, we had an internal code name for it. We call it Ionic. For a reason I actually will not explain that. But, okay, so the ECU itself is quite a complex device that consists of 2 Renesas system on chip. They are different. And a safety controller. And, well, as is expected, it's an ADAS ECU, which means it has a bunch of IOs that are targeted at that market. So it has like, you can connect 8 cameras to each SoC, and then there are like automotive Ethernet gigabit interfaces, and then also automotive and standard Ethernet 100 megabit interfaces, and then you have like CAN, a bunch of CAN connectors, and LIN and FlexRay. Yeah. So the thing is that, and I must admit that brought us a lot of headache in the beginning, is that there are quite a number of safety features already built into the hardware, and it is kind of production ready hardware which can be, you know, like white boxed, and the customer can just take it out and build into their design. And, well, what's then running on the SoCs is Linux, obviously. So, we have, as I said, 2 different Renesas SoCs. One is the Arcar H3, the other one is V3H, which is more ADAS-oriented chip with some interesting hardware accelerators in the silicon. And of course, so as the chips are different, we also have different BSPs from Renesas, and then we did, yeah, what we need to do, yeah. So customize the BSP and bring in our patches for both targets, yeah. What is not really good is that the kernels are different versions, and we didn't want to get into the pain of normalizing that to a single kernel version. And so when I was hired by AVL, the design was already well underway. So we started with a roll your own Yocto distribution, and then at some point later we joined AGL and started using AGL as upstream. So I'm really not aware of anybody trying that yet, except us, yeah? So, and the reasons, I don't have to explain why we took the stable upstream, right? So everybody knows that. But last but not least, at least the portions that we are taking into our builds have been pre-tested by Jan and his teams, so it is less work for us in the end. And how do the builds look like? Well, yeah, we have, of course, then different builds with the same Yocto version dictated by the upstream version of AGL that we are using. And, well, apparently we have to put also some additional content into the builds. And you see here in bold font something that popped up as a must, and this is the SDKs for application developers. Yeah. So actually, for each of the targets, we have like target files, bootloader, device tree, root file system, and then accompanying SDKs and eSDKs. And so, what we did, since it's an ADAS development, there are some things in AGL obviously that are not needed for ADAS developers. So we don't include the graphics framework and the HMI. But having said that, they are still there, obviously. We don't erase metadata, so it can be built. And yeah, theoretically, it can run on the H3 because it does have at least the USB and HDMI connector. But it's somewhat of an overkill. We never tried actually to put a full-fledged AGL demo on our unit. Maybe we could give it a try at some point. It would be interesting now. Yeah? Why I'm saying this now, we will see later. Yeah? And then we had to bring in, as I said, additional ADAS features, which are ROS and specific Python packages. I'll address this later. Yeah. So regardless of that, the basic system and its infrastructure is still AGL upstream, right? So now what is really running on the SoCs is this, yeah? So right now, the left side is still under construction, but the right side already shows what is running on H3. And we have a Xen hypervisor, we have LXC as container framework, and this is running in parallel to Zephyr, RTOS. And why we did that? Well, it's on our agenda, and we expect that at some point our ADAS developers will also come into a situation when they need more than just a single Linux partition to run the code. Yeah? So this is giving us a good base. We are trying to replicate this now on the V3H. There are still some work ahead, but yeah, you will be able, whoever is next week at Embedded World, to see this unit closed, yeah, closed running this setup. You won't be able to see visually because it will still run in foreground our ADAS demo, but still, this is how it will be installed. Yeah, so much about the unit and the software running on it. So what I wanted actually to address with this talk is something else. And this is our experiences with bringing the ADAS into our builds. So first of all, yeah, our target audience is obviously ADAS developers, yeah, who probably we all know that are not necessarily embedded Linux aware, yeah. So we had kind of interesting dialogues with the developers, yeah, that they live in the world of algorithms and yeah, neural networks, so they don't have to know it, but you know, still most of them view, first of all, the system as being some kind of, I don't know, industry PC, or even worse, a Raspberry Pi. And forget sometimes that if you do the serial builds, actually there is no such a person as an administrator who will install stuff on the target, right? So next interesting thing was, yeah, resulting from the first statement is those specific Python packages, yeah? And I have put here like 3 magic letters, pip, yeah? Why? Because they think that the target is, yeah, you have the shell access, yeah, it's networked, so it's easy. If you need some specific Python package, then you install it, right? Well, yeah, but bringing that into the builds can sometimes prove a very, very hairy business, yeah? Because you don't have the recipes, sometimes the dependencies are really weird, and in the end, it's a lot of work, yeah? So, first of all, it's a hassle for us, and the second thing is that normally what they do, before it gets into the ARM target, they use a more powerful platform that enables them all this stuff, probably maybe using Ubuntu or whatever, that enables them to bring in all the stuff they need, compile, test, and then we come to our target and our integration, and what happens is sometimes that the versions don't match of the packages that they use and that we can provide, yeah, through our Yocto build. And then the real nightmare starts, yeah. So you really don't know how the software will behave even if you somehow fix those differences, yeah. So what we quite early came up to is that actually what you need is a proper SDK for everything, including all the things that the developers need. And therefore, it requires yeah, sometimes a lot of coordination with different teams, yeah, to figure out what we exactly need to provide as the system infrastructure for their needs. And then the easiest way to handle this is basically producing 2 sets of target files. One for their target, like an industry PC or whatever, used for development, and the other one is the proper then ARM SDK for our unit. And yeah, so, but it took us some time to figure that out, you know. It was like, yeah, interesting. In any case, so this is the first border case that we had. And the other one deserves its dedicated slide. It's about ROS, yeah. So, obviously, at least when I speak of our ADAS developers, they like to use ROS, yeah? Everybody likes to use ROS, and therefore it brings all the good and the bad actually to our target, because we had some cases where it was missing some dependencies. Okay, that was the very early meta-ROS, but still, yeah, we needed to compile some things directly on the target instead of creating the target file system fully featured. And for some specific projects, it also turned out that I had a look into the libraries provided by a certain commercial vendor. ADAS oriented, I don't think that I have to name them, right? It turned out that through their APIs and libraries, it would have been faster and easier actually to implement what we needed. And that gave me some ideas, about actually how we can bring the two things together in AGL. Yeah, obviously I saw on mailing lists somebody wanted to kind of bring meta-ROS into the AGL builds. But I think this is still a long way ahead, right? So having in mind, I mean, probably Mizuyama-san can say it better. You have discussed it already, right? On the board regarding the possibility of bringing ADAS into AGL. And I know it's on the agenda, but I think so we need to take some things into account. One of those is, including meta-ROS, it looks like a low-hanging fruit, but recently there have been problems with maintenance of meta-ROS layer. So in the last couple of days I didn't check actually the posts, but I know that the company that was doing that is actually pulling out of it, and I don't know how far they have got now, the ROS community with this metal ROS layer, how to deal with it. But what I would like maybe to discuss as a vague idea is why don't we start thinking about creating something similar to this commercial vendor set of lightweight libraries that would provide a consistent API out of the box together with the AGL. I know it requires effort, money, but maybe it's worthy of thinking, to start this activity somehow. And I think I personally have no idea, how to start this. This is just my reflection on the state of things, but I don't know. It might trigger some creative thinking in the community, actually, how to start it, whether to start it, and so, but in the end we would have, like in many cases, then an open source alternative to proprietary solutions with all the benefits of open source approach. So I think this concludes actually my presentation today. I'll leave it open with a big question mark, and I hope that we'll start thinking in this direction. It would surely benefit us as AVL, but probably also the others, right? So giving all the upstream and the activities with automated testing and everything, people would get a stable working environment. So, well, So I thank you for your attention, and in hope that we can kick this discussion off. Thank you. I can take the hat off now, it's still blinding me, but So, thank you.